In this section, we use our proof system to prove some basic results involving quantifiers. While doing so, I will also demonstrate the proof editor you will use this week. Given for all x, for all y, if p of xy, then q of x. We know that for all x, if there exists y, p of xy, then q of x. In general, given a universally quantified implication, it is okay to drop the universal quantifier outside the implication and apply an existential quantifier of the same variable in the antecedent of the implication, provided that the variable does not occur in the consequence of the implication. Now let's move on to a Fitch proof. First, we input the premise. We use the uppercase A for the universal quantifier, uppercase letters for variables, and a colon symbol to separate a quantification from the quantified sentence. Our strategy is to first prove the implication that if there exists y, p of xy, then q of x. And then using universal introduction, we can obtain our goal. So here we go. First, we assume the antecedent of our desired conclusion. We apply universal elimination to strip away the outer quantifier from our premise. We use existential elimination to conclude q of x. Now we use implication introduction to obtain the implication we wanted. Finally, we finish by introducing the universal quantifier in our goal. And we're done. The relationship holds the other way around as well, given that for all x, if there exists y, p of xy, then q of x. We know that for all x, for all y, if p of xy, then q of x. We can convert an existential quantifier in the antecedent of an implication into a universal quantifier outside the implication. Now, let's look at a Fitch proof. As usual, we start with the premise. Our strategy is to first prove the implication that if p of xy, then q of x. Then we can introduce two universal quantifiers to obtain our goal. So here we go. First, we assume the antecedent of our desired implication. We use universal elimination to strip away the universal quantifier of our premise. We use existential introduction to form the antecedent of line 3. Now we can apply implication elimination to obtain q of x. We use implication introduction to get the implication we want. finally, we use universal introduction twice to obtain our goal. Once on the inner variable, then on the outer variable. And we're done.